So question 2 says the point A has coordinate -5, 3, B has coordinate 4, 0, and C has coordinate -1, 5. The line L passes through C, this coordinate, and is perpendicular to AB. Find the equation of L. Give your answer in this format, where A, B, and C are integers. So first of all, we have to plot these 3 points to understand what they are talking about. Without drawing, it will be very hard for us to understand this one. So the first point is -a. The coordinates of A is -5 and 3. So if I point this part as 3, then definitely -5 will be a bit far from 3. So I can say this one is -5 and this one is 3. So that should be the first point, which is A, -5 and 3. What's the next one? It says B is 4 and 0. So 4 should be less than 5. So it should be somewhere here. So 4 and 0. This should be B, 4 and 0. And the last one would be C. And that's going to be -1 and 5. So -1 should be somewhere here and 5 should be more than 3. So let's say this is -1 and this is 5. So this should be the point C over here, -1 and 5. Now, it says L passes through C and is perpendicular to AB. So L must pass from C and it says it's perpendicular to AB. So let's draw this line AB first. So if I draw a line for AB and as it says C is perpendicular to AB. So if I draw C, it will be something like this. Now they are saying to find the equation of line L. To find the equation of this line L, we have to use this formula: y minus y1 equals m x minus x1. That's the formula for finding the equation of a straight line. From here we can see x1, y1 and x1 are one of the coordinates from that particular line, and this m is the gradient of that particular line. So do we have any coordinate of this line L? Yes, we do. We have C over here. And about the gradient, we need to find the gradient. How can we find the gradient over here? We have A and B. So if we can find the gradient of AB using the formula y2 minus y1 divided by x2 minus x1. If we use this formula to find the gradient of AB, we can easily find the gradient for the perpendicular line as well. Because if the gradient of a particular line is m, then the gradient of the perpendicular line will be -1 over m. Now let's start solving the math. So first of all, we have to find the gradient of AB by using the formula y2 minus y1 divided by x2 minus x1. So from here we can say the coordinate of A can be x1 and y1, and the coordinate of B can be said as x2 and y2. If we use this formula over here, y2 minus y1 divided by x2 minus x1, we can find the gradient, and that's going to be -1 over 3. We now have the gradient of AB. Now we need to find the gradient of this perpendicular line, which is going to be L. Now, as I've mentioned that the format of finding the gradient of a perpendicular line, we have to use this formula -1 over m. So we will use this gradient's result and put it over here, -1 over 3. And when we arrange, we get the final result as 3. So now we have our gradient of that particular line L, which is going to be 3. So we can use the formula y minus y1 equals m x minus x1. Over here, we have to substitute m as 3, and y1 and x1 can be any of the coordinates of that particular line. So we only know the coordinate, which is C. So we will use this coordinate of C, where x is -1 and y is 5 over here. So instead of y1, we are going to write 5, and instead of x1, we are going to write -1 over here. When we arrange this formula, we get y equals 36 plus 8. In the question, we have to also notice that it says, give your answer in this format. To transfer it into this format, we have to transfer this y to the other side. It will become -y. So 36 minus y plus 8 equals 0. That's our final answer of A. Let's move to question B. It says the line L intersects AB at the point D. That means this line L, this line intersects AB at the point D. So you can see this should be the point D. Now they are asking us to find the coordinates of, or show that the coordinates of D are -2 and 2. So to find the coordinates of any intersection point of two line, we have to use the equation of those two line, and using simultaneous equation we can find the coordinates. So we already know the equation for L. We now need to find the equation for AB. So we have to use the same format, y minus y1 equals m x minus x1, where y1 and x1 can be the coordinates of any of these 2 points. So we can use either A or B. And then we have to use the gradient. If you remember, we have already found the gradient of AB from last time. Over here, the gradient of AB is -1/3. So we can use that, and we can use any of the 2 coordinates of from A and B to find the equation for this particular line AB. So over here, you can see the equation of this line. They have found it by using the B's coordinate, which is 4 and 0. They have used that, and then they also use the gradient, which is -1/3. And now we have the equation of AB. Now we also have the equation of L, so we have to use simultaneous equation here. If you use simultaneous equation, you will finally find the result of x as -2 and y's coordinate as 2, where we can say it's shown. Let's move to the next question. It says, show that L is not perpendicular bisector of AB. What do we mean by bisector? Bi means 2. So that means it's saying show that L, the line L, do not cut the line AB into 2 parts, 2 equal parts. We can clearly see that it's not 2 equal parts, right? But still we have to prove it. How can we prove it? The format for proving it would be, we can try to find the midpoint of A and B, first of all. If we can find the midpoint of AB, and if the coordinates do not match with D, we can say that it's shown that D, the line L, is not a perpendicular bisector of AB. To find the midpoint of AB, we have to use the formula average of x and then average of y, the coordinates of 2 points. If we use that, we can find the midpoint. So we will use the coordinates of A and B over here. So from here, we can see the midpoints. They have used that formula, the average of x and the average of y. If we do that, we can finally find the result as -1, -half, and 3/2, which do not match with the coordinate of D. That means it is not perpendicular bisector. You see, it do not match with the previous one, which is the coordinates of D. All right, let's move to the last question, D, where it says find the value of tan ABC. Give your answer in its simplest form. So tan ABC means A, B, and C. They're talking about this angle. Okay, now we know that to find the tan ABC, we can use the formula for the ratio for tan is opposite over adjacent. If we have a right angle triangle, we can use this formula of opposite and adjacent to find the angle of this one, this angle. So from here, if we want to find this angle, we can use the length of DC as opposite and DB, and finally find the angle, this one. We can ignore this A, although the question says ABC. We can just simply try to find DBC. That should work. To find DBC, we have to find the length of opposite, which is DC over here. So to find the length of DC, we can use the length formula, which is change in y whole square plus change in the x coordinate whole square. That comes from the Pythagoras theorem. So if we use this formula, if we use the coordinates of D and C and substitute this into this formula, we can easily find the length of D and C. We can use the same format to find DB, and then we can just substitute into opposite and adjacent to find our final result. Let's see how it can be done. So over here we can see the length of BD. They have used that formula to find the length of BD as root 40, square root of 40, and the length of CD is square root of 10. So opposite here is CD. So the length of CD is square root of 10, and the adjacent is BD over here. So the length of BD is root 40, square root of 40. So you see square root of 10 over square root of 40. When you just find the answer using calculator, you will find your answer as half. That's the end of question 2, everyone. Thank you.